Okay, so I'm going to have a quick look at the Determining Stoichiometry Coefficients lab report. This is one of the easier labs, but students often get off on the wrong track. So the general premise is that you have four solutions, A, B, C, and D, and you're going to mix them together in all possible combinations. And then for those that react, those combinations that react, you're going to write a balanced chemical equation. So you've got two things to do. First of all is identify if any reactions occur. And then the second thing to do is if a reaction does occur, you're going to write the balanced equation for it. So what you want to do is go through each of the 6 possible combinations and identify if a reaction actually occurs. Once we've got that worked out, then we can work on the balancing. So let's have a look at that, and we'll just do a few examples to see. So I'm going to go over to the virtual lab, and I'm going to grab some A, and my first combo is A being mixed with B. So all I'm going to do is just have a note to begin with. I've only got A present in the solution. Don't worry about these things here that have a concentration of less than 10 to the minus 6. We're going to ignore that. In the other solution, I've only got B. Again, we've got a little bit of these other things here. These are the auto-ionization products of water. We're going to learn about that in Chemistry 163, but they're not important at the moment. Their concentration is too small to be relevant. So I'm going to put all of the A into the B. It doesn't matter how much I put in. I'm just looking to see if anything new forms. And after mixing, I see that I only have A and B. You'll see that the concentration has gone down a little bit, or it's gone down by a factor of a half because we doubled the volume, but no new substances have formed. So I'm just going to make a note over here that when I mix A and B, no reaction occurs. So now I'm going to clear off the workbench and I'm going to mix A with C. So there's A, you can see it only has A in it, and then I'm going to grab some C, there's C, and I'm going to dump the whole of the A in again. There we go. And in this case, it was A with C, right? So all of the C got used up, there's none of that remaining. There's the A, but instead of it being 0.5 moles per liter this time, it's 0.25 moles per liter, which indicates that some reacted. But what I'm really looking for here is that there are two new things there, B and D. So I've got some products. B and D are my products. So I'm going to make a note of that, B and D. Now, what's important is I need to go back and figure out what the coefficients are. So I'm going to get A moles of A will react with C moles of C to produce B moles of B and D moles of D. And I'm going to have to go back there and figure out what those coefficients are. And so then I'll go on to the next one, which is going to be A and D. So I'm going to grab some A, there it is, grab some D, and the same process, right? There we go. And see if anything happens, and when I mix the two together, I only have A and D in there. So that one's going to be also marked as no reaction. No new products formed. Okay, so I won't do all 6 of the combos, but you'll go through and you'll identify what pairs react. So once you find one that reacts, then now you're going to have to figure out what the coefficients are in order to balance it. So let's go over here and have a look at how I'm going to tackle this, right? So that's what I want to balance. And so the best way to do this, I find, is in what we call a reaction table. So what do the coefficients represent? This is saying that A moles of A reacts with C moles of C to produce B moles of B and D moles of D. So what we need to know is how are the moles of things changing. So what I want to calculate is how many moles of each component did I have before I mixed the things together, and then how many moles of each thing do I have after mixing. And the amount that the reactants get used up by, that's going to be represented by my coefficients for my reactants, and the amounts of products that are produced are going to be represented by the coefficients of my products. So first thing I need to do is calculate the moles of each thing I had before mixing. And it sounds kind of obvious, but we had no moles of the products before mixing. So remember I mixed 100 mils of each one. So I had 100 mils of A and it had a concentration of 1 mole per liter of A. So 100 mils is the same as 0.1 liters, right? Because we get 10 to the minus 3 liters for every 1 milliliter. So I started with 0.1 liters, and then my concentration was 1 mole per liter, 1 mole of A per liter. So I began with, you guessed it, 0.1 mole of A. There it is. Okay. So I had 0.1 mole of A. Now, how much C did I have? Well, I also had 100 mils of C, and that also had a concentration of 1 mole per liter. So I also had 0.1 moles of C. So this was pretty easy. We've already got our first line. If you don't believe me, let's add the C in. There we go, C. And we have 100 mils of C, and it was 1 mole per liter. Okay, so now what am I going to do? I'm going to put all of my A into my C, the whole thing. Now, it doesn't matter, you can do this with any amounts. The math is going to work out in the end. So now what do I have? Well, now I just have one container. The total volume is 200 milliliters or 0.2 liters. And I have no C, so that's going to be really easy to calculate. And then I have 0.25 moles per liter of everything else. So I only have to do like one bit of math here because all of these numbers are going to be the same for the number of moles afterwards. So that's kind of nice. So for C afterwards, I've got 0 moles. And then for the other ones, I had 200 milliliters. And I know that I get 10 to the minus 3 liters for every 1 milliliter, or that is 0.2 liters. Many of you will do that in your head. And then what was my concentration after mixing? It was 0.25 moles per liter, and I've got 0.2 liters, so that's going to end up being 0.05 moles, right? So there we go, 0.25 times 0.2, 0.05. Easy. All right. So that is the number of moles of everything else. 0.05, 0.05, and 0.05. Now, how do I get to change in something? Well, it's always the final value minus the initial value, isn't it? So my final value is my value after mixing here. So let's just do that for A, or we can do it for C because that's really easy, isn't it? So my final value was 0 and my initial value was 0.1. So it went down by 0.1. So 0.1 moles of C got consumed. Now let's do A. My final value was 0.05. My initial value was 0.1. So that means that 0.05 of A got consumed. Minus 0.0. We should probably zoom out a little so we can actually read it. So A went down by 0.05. All right. Now, the ones for B and D are going to be very simple because we had our final value is 0.05 and our initial value is 0. So that means that that went up by 0.05, and that's going to be the same for both of them, right? So 0.05 and 0.05. So these are the numbers that we're interested in. Right? Those are the numbers that we're interested in. So 0.05 moles of A got consumed, 0.1 mole of C got consumed to produce 0.05 moles of B and 0.05 moles of D. Now, if you're good, you can see what the coefficients are going to be immediately, right? The number of moles of B and D that I am producing are exactly the same as the number of moles of A that I am consuming. You can also perhaps see that the number of moles of C that I am consuming is twice the number of moles of A that I am consuming. So the coefficients here would be 1, 2, 1, 1. Now, if you can't see that, all we do is we pick the smallest number out of this set and we divide everything by it. And that'll give us the smallest whole number ratio. And so now we see that we have 1A reacting with 2 C's to give 1B and 1D. So we got that worked out. So what I'd do at this point is I'd go back and I'm going to keep checking all of my others, right? So I've got B and C, B and D, C and D to check. And anywhere that I observe that a product is formed, then I have to go through this process of figuring out how many moles of each reactant were consumed, how many moles of each product were produced, and from that getting my balanced equation. And I like to use, like I said, this reaction table, and that really helps me organize my thoughts. Okay, I hope you found that helpful. I'll go through this again later, but I just wanted to get a quick video out there just to help folks who are asking me about this.